Hello. Good morning, everyone. Welcome to the session of Achieving Petabyte-Scale Data Ingestion with Azure Data Factory. My name is Linda Wang. I'm the program manager from Azure Data Factory product group. So before I start the session, I'd like to do a quick poll. Like, how many of you attended ADF sessions during the past few days? Can you just put your hands on? Oh, great. And how many of you are using Azure Data Factory specifically for data ingestion for your solution? Perfect. Thank you. So in this session, we will talk about, briefly recap what is Azure Data Factory, which provides code-free ETL and ELT at scale capability for customer. Then we will do deep dive into data ingestion specifically. We will talk about the customer cases, the best practices, the capability we provide to empower the data ingestion for you, and also the patterns we see. Then we will do some demo and also the Q&As. So start with Azure Data Factory. What is Azure Data Factory? It is a fully managed, serverless, highly scalable, hybrid data integration service in the cloud on Azure. So it provides a bunch of rich capabilities. It includes data movement and data transformation at scale. It provides 90+ connectors, and it also provides visual-based transformation using data flow. It is a hybrid model, pipeline model. It can reach your data store either sitting on-prem, in the cloud, or behind the VNet, anywhere in the world. It provides ease of authoring and monitoring experience, single pane of monitoring experience for you to easily construct your workload and monitor that for operationalization. Last but not least, it also provides lift and shift your existing on-prem ETL packages, SSS packages, to the cloud. So with all those rich capabilities provided by ADF, if we double-click it a little bit, this is the overall architecture that Azure Data Factory actually works. So from a very top, you see that there's a UI and SDK way to create, to author, and to monitor Azure Data Factory objects. Then Azure Data Factory as a managed data integration service in the cloud, you can construct pipelines which maps to your workflow. Within pipelines, you have a bunch of activities, each doing some operation, for example, copy data from A to B, or doing the transformation, for example. Then those pipelines can be orchestrated by Azure Data Factory service. Once that activity is actually being executed, it's being executed on a concept called, on an object called integration runtime. That is actually an executor that really empowers or do this actual activity runs. On the integration runtime, it can do the data movement, copy from A to B, or do the data flow, pipeline activity execution, or doing the SSS package execution. So there are two flavors of integration runtime. One is self-hosted. It's you download and install some software behind your firewall to enable hybrid connectivity, or its right-hand side is Azure integration runtime, which is fully managed infra by ADF, and is highly scalable. So keep that architecture in mind. We will talk about the similar architecture later to deep dive on, for different scenarios, how it actually works behind the scene. So data movement, or you say data ingestion, data copy, which is the first and foremost step for analytics workloads in Azure. So customers just bring data from various sources into Azure, then continue with their analysis transformation kind of workloads analytics. So with data movement scenarios, we see there are mainly two scenarios that there's a needs, and also ADF fits pretty well inside there. So the first one is data migration for data lake or enterprise data warehouse. So some of you may have existing data warehouse or data lake sitting either in other cloud like Amazon or Google, or sitting on-prem like you have on-prem Hadoop. Or you have enterprise data warehouse like Oracle and Netezza sitting on-prem, that you want to move those workloads and analytics workloads onto the Azure. And the first step there is to move the data along from those sources into Azure. So for this pattern of this scenario of data movement, Azure Data Factory provides best-in-class performance and scalability. It can handle PB level lake migration and dozens TB of lake warehouse migration. It can tackle both incremental and historical data migration with pay-as-you-go manner. The second workload or scenario is data ingestion for ETL, which is, we call that modern data warehouse pattern, that you bring data from various sources into a lake, and on top you do the data preparation, data transformation, data enrichment, prediction, then push into the serving layer. Either it's the data warehouse for reporting, or it's a database for app consumption. With those scenarios, ADF provides rich connectivities for you. It can connect to data sitting anywhere, and it provides enterprise-grade security for you. It's very easy to author, to manage, to monitor. So for data migration specifically, usually we see customer ask, shall I do offline migration, which is disk shipping, using, for example, in Azure provide data box, or is that possible to do that online migration, for example, using Azure Data Factory? So here are the key considerations. Mainly 3 aspects. What's the size of your data? What's the available bandwidth? And what's your expected migration window? So here is just a simple calculation. Each row is your data size, and column is your available bandwidth. So Azure Data Factory is highly scalable to utilize your network and network bandwidth and storage IOs. So with that in mind, this is just calculate data size divided by the bandwidth, available bandwidth. Then you can calculate and get the migration window. If we take 2 weeks migration window as an acceptable criteria, then you can see that for the orange cells, that you can do that online with Azure Data Factory. And for those blue cells, which is either you have too large of data or you have too slow of your network, then you can go with the offline migrations. Well, with that, you can see that even PB level data with like public network or with high-speed private link, you can actually achieve the data migration using Azure Data Factory. So I want to share with you some of the customer cases we work with similar Azure data migration scenario or data ingestion for ETL scenario, that they really use Azure Data Factory data copy capability to fulfill their business needs. So the first scenario is to migrate data from Amazon S3 into Azure storage. So they're already running some analytics workloads on Amazon, and they want to move them onto Azure. The first is to copy the data. So the first case, I must the customer name here, but all the requirements, all the workloads, and the results are real cases. So the first one, with 2 PB data sitting on Amazon. So their requirements is to copy that as fast as possible onto Azure, minimize the migration window. So with ADF, they actually achieve 2 PB data migrated within 11 days. Initial load, 2.1 gigabyte per second, and incremental is even higher with 3.6 gigabyte per second. And the second case is similar with 1 PB data from S3 to Blob. While instead of going through the public network, they set up a private channel from, between Amazon and Azure. The consideration behind is for US cost and for security. With that dedicated channel with 10 Gbps, small b, they actually achieve almost 800 megabytes per second, which is on average 60% of utilization of their private channel. And for peak throughput is even higher than this. So besides the lake migration, the third case is actually a data warehouse migration from on-prem Netezza to Azure Data Lake storage. So they are trying to modernize their on-prem data warehouse into modern data warehouse. From the data warehouse-based thing into the lake, then on top of the lake, they will build the analytics and transformations. So instead of comparing to previous one, who try to maximize the throughput, this one, they want to minimize or control the impact on the data store, in which case they have specific data migration window, which is off work hours, and they have limit on number of connections to their data store to minimize the impact on their data store. Even with these various requirements, Azure Data Factory can perfectly solve that as well. So with 25 terabytes of data from on-prem Netezza to the cloud, fitting their requirements of migration window and migration limits, they finished that within 3 weeks. The first case is a typical MDW pattern. ingest data from various sources, bring data from data silos into an enterprise data lake. On top, with different business units, business need, they can use a unified architecture to do the analysis, do the data transformation, do data analytics, and serving for reporting. So this customer wants a single tool that provides best scale, perf, easy to use and management, and they choose Azure Data Factory. So they use Azure Data Factory to copy from more than 24 of type of data stores. This including Amazon S3, Google Cloud Storage, Google BigQuery, and also on-prem data stores, different databases, file storage, all etc. And also among Azure Data Services. So this is one of the, maybe you see that modern data warehouse pattern here and there in different sessions. Azure Data Factory is the one that to provide you the capability to really ingest data from various sources into the cloud. So with all those customer wins, how does Azure Data Factory copy capability actually fulfill the need? How it actually works? Then next, I will share more technical insights from different perspectives, how they build the solution, how is the different considerations, and the best practices. So usually when customers build a solution, they go through several phases. First is assess. Assess the workloads, assess the requirements, and assess how Azure Data Factory can possibly fit in to solve the needs. Then functional POC to prove everything works as expected. Then is the performance POC to really test the perf and scale of Azure Data Factory for that solution. Then if everything works as expected, they can deploy this from dev to QA to production. So when we say assess, we actually can group the questions or requirements into these several aspects. Connectivity. Whether the data store, source and sink, and formats can be connected from Azure Data Factory. Networking. Is that on-prem? Is that cloud? Is that VNet? How can I set things up to really tackle different scenarios? Data loading patterns. Is that historical, one-time huge volume of data copy? Or is that incremental catch-ups? Scale. What's the data size? How many objects you need to scale to? And performance. What's the performance expectation? And security. For large enterprise customer, usually we hear from you that there are specific security requirements, security policy from your organization that you have to follow. So for all those perspectives, can ADF really meet the requirements, and how? Usually the answer is yes. So we will talk about each area in details. So breadth of connectivity. You may hear that we talk about Azure Data Factory support more than 90 built-in connectors, and this is keep growing month over month. We keep enhancing the existing connectors as well. So this is a current snapshot of all the data stores that ADF can connect to natively. It covers almost all the Azure data services, Azure Storage with Blob API or ADF's Gen 2 API, different database flavors like SQL, MySQL, PostgreSQL, Cosmos DB. And there are also outside of Azure, different database and data warehouse, like SQL Server, Oracle, Teradata, Netezza, SAP, just name it. Different file storage, S3, Cloud Storage, FTP, SFTP. There are NoSQLs and rich set of SaaS applications, like Dynamics, Salesforce, SAP ECC, Office 365. So you can literally put data from anywhere and put into the Azure. And we also support rich set of formats. Others delimit test JSON, or it's big data workloads like Parquet and ORC. We can both parse it and generate files in these formats. What if the data store you want to connect is not in this list? It's not end of the story. So here is the connector code extensibility options that you can further evaluate if you don't find your connector in the table. If it's database or data warehouse, you can usually use generic ODBC connector with a corresponding ODBC driver. If it's SaaS application or it's some application you build in your house, then you can use generic REST API, generic REST connector, Or if they provide OData feeds, you can connect via the OData connector as well. And for all the others, maybe your data store provides some native utility that can dump data to somewhere, for example, to file storage. Then you can let ADF to pick up from there and continue your end-to-end big data analytics workflow. So with those connector called accessibility, it can actually help you reach much more than 90 plus data stores in the world. Network configurations. It's a similar diagram, while there are actually two flavors of data copy. One is cloud-to-cloud copy. When we say cloud-to-cloud, it means your data store is publicly accessible by Azure ADF service. So right-hand side is the similar diagram. It's just for this cloud-to-cloud copy, it's actually empowered by an executor called Azure Integration Runtime. That is a fully managed infra. It's serverless. It's highly scalable. It's pay-as-you-go. And that service, you can also choose that for each of the data copy, how much machine power you want to use to really execute that data copy from source to sink. You can imagine that it's a bunch of VM, and ADF will just give you that number of machine power when really you execute that data copy capabilities. And that IR will retrieve data from the source and write data to the destination. And the machine power there is actually represented by a term we call that data integration units. That is a combination of CPUs, memories, etc. underneath. Versus for hybrid copy, if your data is sitting behind the firewall in the VNet, then that kind of copy is empowered by self-hosted integration runtime, which is a component you download, install, and register to the Azure Data Factory. And that component sitting on a machine managed by you will be used to retrieve data from source and write data to the destination. That component, we provide auto updates to keep that up to date and provide you the latest capability and enhancements. It's have the HA, high availability and scale out capability that you can, for each of the integration runtime, you can register up to 4 nodes to really scale out for your growing business needs. And it's active-active. Each node can handle multiple concurrent copy activity runs in parallel as well. This is really the way to scale and to meet your scalability and your growing business need. Well, with this self-host IR, there are different network or setup provision ways. So you can set up, if you are going through public network from on-prem to cloud, you set up the self-host IR on-prem inside your CorpNet. Then that way, that self-host IR inside your CorpNet will retrieve data from source and push into the Azure going through the public network. If you have express route, private paying to connect your on-prem to the cloud, then you can, in contrast, set up that self-host integration runtime in the Azure VM. That way, it's more easy to provision, easy to manage and scale, and also will provide an ARM template for you to easily set it up. That way, self-host IR will connect back to on-prem via the express route private paying. And it works with all the Azure VNet story as well. Similar to the previous one, if it's between cloud, while there's a private pairing in between, like the previous customer case I mentioned, they use Azure Express Route and Amazon Direct Connect to establish a private channel. In this kind of topology, you can also choose to provision the self-hosted integration runtime in Azure VM. Then it will connect back to Amazon using that private channel, then right to the Azure data stores. So with different options, topologies, different scenario, this is a summary slide. For different cases, for example, on-prem to cloud, the suggested way is you have an express route, which is a dedicated channel. It's more secure with predictable performance. In that topology, you provision the self-host IR in the cloud. Or if you go with public network for now, you can put that components on-prem. Cloud to cloud, majority cases public internet, then you can use the fully managed Azure integration runtime. Unless you have a private link in between, then you can choose the self-hosted integration runtime. There are also 2 upcoming nodes there. We hear that many customer feedback, you want VNet Story and Azure IR to work with this. So we are actively working on that. So in the future, the Azure IR, which is a managed service, can fully support the VNet scenario as well. So for those 2 options, you no longer need the self-hosted integration runtime. This is to eliminate the need of setting up and provision and managing those infras of VNet Story. So stay tuned. Security. So when we raise security questions or hear security questions, it's actually there are multiple perspectives. First one is how do you authenticate to the data store and how you store the credential. So the suggestion for authentication for Azure services, we recommend service-to-service authentication. We support AAD-based managed identity and service principal authentication to Azure data stores. And for other data stores, for each connector, there are various type of authentication types fitting for that data store. For example, basic auth or Windows auth, for example. And for credential management, which is critical for each of you. So Azure Data Factory integrates with Azure Key Vault, which is the secure way to store the credential. What you give to Azure Data Factory is just a pointer to your credential, and only upon the execution, it will retrieve the credential from AKV and use that to connect to your data store. This also eases your credential rotation. You can just update the credential in the AKV, and ADF can retrieve the latest during execution. If you don't want to use AKV for now, you can also provide credential to ADF, and ADF guarantee that your credential is encrypted and securely stored within ADF scope. So especially for self-hosted IR, that for your on-prem credential, which is even more critical for you, the credential is encrypted and stored on that self-hosted IR machine. That only ADF and only upon activity execution, the credential will be decrypted and used. No other ways to really use and access that credential. So besides the credential authentication, there are also data security, either during the transit or at rest. So ADF, when moving the data around, we utilize the TLS, secure channel, or HTTPS, to really move data in secure manner. And also for data security at rest, ADF integrated with data stores native data encryption mechanisms, like database, TDE, or storage SSE. This is the ways to guarantee that your data, even during the transition or when it's writing to the destination, is securely stored. Next, I want to talk about the different patterns and best practice, how to retrieve data from different type of data stores. So we largely divided into a file-based store and non-file-based, as well as relational or SaaS applications. So for file-based stores, it's quite easy to configure in ADF. It's just you're pointing to a path, either it's a source or destination. ADF will just retrieve the data from there or write data to there. So during the copy, ADF copy multiple files in parallel. And within each file, we copy multiple chunks in parallel as well. This is just to help you achieve the best performance in there. While for incremental copy, if it's a big data workload, you already have the datetime either in your path or in your file name. You can use ADF's tumbling window trigger, where your data is time sliced, and along with dynamic expressions and variables to construct a dynamic path. For example, for this one, you can have some static parts and some expressions. And during each run, the actual time window will be fed from the ADF control flow, like orchestrator. That way, you can really retrieve the delta from that specific path. Or we can also retrieve data based on the last modified date of the metadata to retrieve the delta. For relational database, we actually issue the query to the source and retrieve the data from there. And for some of the data stores, our Data Factory even have more performance ways. We will issue multiple queries, like auto-split based on the query configuration you specified, to copy data in parallel and writing data in parallel. That is to achieve better performance for your case. When we talk about the incremental copy for relational data stores, they are actually different options fitting to different data patterns based on your needs. So similar as the file-based ones, if you have a time-based, for fact table, you have a time-based, a timestamp column, like created time or last modified time. You can also use Data Factory's expression and the system variables to construct dynamic query, where in the warehouse, you can just filter the delta records from there. Or if you have a high watermark code, that's an incremental column, there's a way that with other activities combined, you can have a workflow to achieve the high watermark with incremental copy. That is, you have a control table to store the high watermark column value that is copied to last time, then use that to really generate a dynamic query to copy the delta for this time. If it's a dynamic dimension table that is small in size, you can choose to copy them all and overwrite in the destination. And if you're using SQL Server or other SQL database, ADF integrated with the chain tracking as well. So you can leverage the chain tracking mechanism and use the combine with the high watermark mechanism. That is the system table of chain tracking can serve as the high watermark and to retrieve the delta as well. So with all those technical details that I shared, when you really do the functional POC, just do a recap here. So connectivity, just validate if ADF's connector can really connect to your data store, source and sink and formats as you expected. It can pull out the data with the right value and right shape for your requirements. Network, you can choose between managed Azure integration runtime versus the self-hosted components. Either is on-prem or in the VM. Security, design your ways to handle the credential, suggested ways as a Key Vault, and service-to-service authentications. And loading patterns for both historical and incremental copies. So we provide various ways to author that. I will show the demo later as well. So for first-time users or for simple kind of workloads, there's a copy data tool, which is a wizard-based thing. You don't need to understand the underneath object model. You just focus on the source and destination configurations. Then that wizard will generate all the configurations for you. Or we have a rich templates gallery that for different patterns of data loading, you can easily start from there as well. So after you prove that functionality-wise it works, then we also, here is the suggestion for performance POC. Usually when they do the performance test, because when we talk about performance, it actually varies based on the data store, based on the data shape, data schema, your network topology, your network bandwidth, database, I/O, all etc. That we suggest that you really test that with your data, inside your environment. So you can pick a representative workloads to really set it up and get a baseline, get a test number, and compare that with your expectation, identify the bottleneck, and tune the settings, then iterate until you get a good enough performance. So usually, ADF actually provide adaptive settings to adapt to different workloads. Well, if it's not enough, not sufficient, or not good enough, mapping to your expectation, you can further tune compared to the default settings. So just to understand how ADF copy scales, we talk about different pieces. But if we combine them together, how Azure Data Factory works. So you have data stores sitting on-prem in Azure, in other places outside of Azure. And this is the Azure Data Factory, orchestration from the cloud, executor on Azure IR or on self-hosted IR. Those executors will connect to the source and destinations during the activity execution. So here are the few points or few places that you can really tune and understand how ADF can really scale to, we said that we can fully utilize your network bandwidth, etc. So on the top, from orchestration perspective, we have flexible control flow. You can trigger a number of copy activity runs to tackle different set of data, either from different data store, from different objects, or even you do the data partition to put different parts of data from the same, for example, table or folder. Then when it's executed on the IR, you can control for Azure IR how much machine power to use. You can configure the data integration units for the copy runs. While for self-host IR, you actually can control the machine size. You can control the concurrent numbers that being executed in parallel. And also you can scale out to multiple nodes to tackle that. And when you really trigger a copy activity wrong, when you go to the monitoring page, actually this is a sample monitoring, just to showcase the monitoring experience. You can see that we provide the source and destination, how much data read and write, the throughput. And we, in some cases, if we identify some bottleneck for you, you will see a performance tip on top that you can really tune the settings. Usually it's maybe outside of Azure, like your data stores being the bottleneck. Then you can change that configuration as well. And we also show more metrics on what is, for example, the DIU being used, what is the parallel copy, and how long it's being queued, or how long the query is being executed when retrieving, when Azure Data Factory wait for the data to be retrieved from the source. All those metrics help you understand for each of the copy how that works and what is the bottleneck and how you can resolve that. We also provide a comprehensive performance tuning document that you can read through, and it's keep enriching as well. So usually for modern rate data workloads, the copy activity, the default setting can just fulfill your needs. But for like petabyte scale data movement, the suggestion is you can partition the data and actually load them partition by partition. That is really the way that you can scale to handle large data sets. This is also demonstrate another way is some customers have that is metadata driven, that you can have a templatized pipeline, then it take in the actual, for example, the source, the sink, the query during the execution time. So this is just one example that customer use this to achieve petabyte scale data movement from source to sink. So there's a control table that store for different partitions what is the actual source to retrieve. And in the pipeline, there are actually many surrounding capabilities just besides copy activity. So you can do a lookup to really get all those metadata settings from the control table, then pass that to a for each. The for each will just iterate through all the partitions or all the different data parts. Then within the for each, you can do a data copy. The data copy will tackle each of the partition, either is concurrently or one by one. Then for this case, even more advanced, you can have a store procedure to set back the status of that, of each partition. And that will ease you to do the next iteration as well. So for like 100 TB, maybe you can do that with a single partition, with a single copy activity. While if it's really scaled to petabytes, you can leverage these ways to partition the data and let copy handle them one by one. So also here are some suggestions on how you can partition the data. So for each partition, you can test a set of data first, and you can tune that to until that each partition can achieve great performance. For example, for cloud copy, you can tune up the DIU settings, data integration unit settings. If each partition is good enough, you can just iterate through them one by one. Or you can, if it's not good enough, you can also choose to copy multiple partitions in parallel as well. This is actually a similar pattern. It's just a Netezza to ADLS copy. It's quite similar to the previous one. You can have a control table. Instead of the paths, you can have different queries. And it will just iterate through all the queries to copy different parts of data. And in this example, not only you can do copy, and after the copy, you can chain with the transformation as well. This way that you have a single pipeline configuration, but it can handle different part of the data as well. You can also use this way to even copy different sources to ease your pipeline configurations. So those are all the like parameterization capability and flexibility that Azure Data Factory provides in box. So this is just a screenshot of the template gallery, there's a copy option there, and we build many templates for different workloads, like bulk copy from lake migration, or bulk copy from databases, incremental copy from databases, and different source and destination combinations as well. So I will show you some demos next, including and beyond this. So in case you haven't seen the Azure Data Factory demo anywhere, so this is the Azure Data Factory homepage that you can easily provision like other Azure services. You can just new and create a data factory, and this is the landing page. And here, author and monitor, this is the entry that will jump to the rich authoring experience that ADF provides. So this is the landing page of that authoring UI. So there are some quick starts or shortcuts. You can create a pipeline, create data flow, copy data, and there are some videos and tutorials linked from there as well. And here, you can jump to the authoring type. I will just use another tab. So here, it will be the authoring UI. So it will list all the resources, and right-hand side is the canvas. So here is already a provisioned copy activity. For each copy activity, you simply configure the source and the sink. In this case, we actually do a S3 to cloud, to ADLS copy. So in the source, it points to a S3 path, and in the destination, it points to an ADLS dataset as well. While for new users, if you don't want to get into this object model, or if your workload is moderate, we also provide a copy data wizard. In this wizard, actually, it's just a few configurations. You configure the source, configure destination, for example. Here are my configurations of each data source. For S3, you just give the connection of this. And for each data store, we just ask for different configurations. It can browse different the paths for you. And if you choose the databases, it just lists all the tables for you. Then you can easily configure that. So you can also choose how to copy the data, etc. And then you can move to you can choose the binary copy, and you can choose the destination. It's the similar pattern. So this is really an easy way for you to get started. Then what happens when you really create this, ADF will just generate the pipeline with the copy activity, with the configuration you input in the UI. That is the easy way for you to get started as well. So I already have one copy activity specified. Then you can choose to trigger now, or you can attach to a trigger. So the trigger can be scheduled or tumbling window trigger or event-based, anything. And you can trigger from outside of ADF as well. And I want to show you, I won't run that now, and I already have a previous run of the same copy pipeline with the copy activity. So this is the monitoring experience that when you get into that, you can actually see that it's detailed monitoring of that copy activity. Then here is the place that you can really see the copy activity results. So for this pipeline sample run, I actually copied 1 TB of data from S3 to ADLS Gen 2. And the average throughput with single copy activity achieved is almost near 3 gigabytes per second. So ADF provides you the best-in-class performance with the default thing. And you can see that in this case, I use 128 DIUs here. And it's not yet the biggest. We can even double this. So keep in mind that ADF is really easy to scale and issue a lot of requests to your data store. And if your data store, there are some throttling or limited connections, you don't really need that much DIUs or parallel copies or concurrencies. So this is the monitoring page. For each of the data runs, copy runs, you will see this as well. So also I also talk about for complex models. Here is the pipeline from the template. And you can see that for copy, we have a bunch of built-in templates there for different kind of workloads. For example, I show a sample example of S3 to ADLS with partition thing. So you can see that this is actually, we built the same templates for you. You can do a lookup and for each inside this data copy. You simply just give the connections of your case. For example, I already have the pre-configured thing. Then you choose use this template. We just generate all the configurations for you. Lookup to get the partition list, pass-to for each. And here, you can see that all those can be parameterized. This is the templatized pipeline that you can use, and the actual value can be passed during the runtime to there. So this is also the way that you can get to different patterns of copy that is easy to configure. Also, ADF provides rich monitoring experience for your operationalized workloads. That this is the monitoring for historical workloads. You can also see that in the Gantt view, that based on the different times, how those different activity runs is being executed. Okay. So we talk about the current capability. What will come next? So this is the Azure Data Factory roadmap, including the data movement. So if you see the data movement parts, during the past, we keep adding the connectors, keep improving that, and we provide a bunch of capabilities like skip 40 row, different capabilities inside the copy. And what's coming next? We will provide more connectors like Snowflake SFTP, and we will provide resume from failure points, and other skip 40 kind of capability, and data consistency check and loggings, just to help you understand more on what happens. And also, we will provide more rich self-diagnostic for perf tunings. And enterprise readiness, this is also important. I mentioned that we are working on supporting Azure IR for VNet scenario. And also, we just onboarded to the trusted Microsoft service. If your storage have a firewall setting that to allow Microsoft trusted service that already work with Azure IR. And we will next provide fixed IP for that as well, just to provide you more options to have a way to use the Azure managed infra to really empower your different workloads, which is highly scalable and performant. So that's all for the content I want to cover. I will open for, I think I have a few minutes for Q&A. And if I cannot cover your questions, feel free to stop by our booth, and I'd like to learn more from you as well. So any questions? Hi.
So my question is around the data set.
Yeah.
And when you're creating the data set sync side, you go and find the connector where you want it to write up, and then you have to select the format.
Yes.
The data format you want to do. But sometimes I make a mistake, choose the wrong format. Is there a way that I could change the format without deleting that data set and recreating it a new one?
So currently, the data set is format-based for file connectors. But actually, creating a data set is not that hard, I'd say. Yeah, I understand that question. So changing the format currently requires a different format, different data set. Yeah, that's correct.
Why is it depending on that?
So currently, the data set's format-based and is decoupled from the data store. So if you want to choose a format and you want to switch the data store, you don't need to change the data set. It's more about how we pivot the data there.
Put in the enhancement?
Feedback take.
I went to a session yesterday on the Power BI data flows,
Yeah.
and it seems like it's very much aimed at the same sort of thing, GUI-driven ETL service. How is Azure Data Factory different from that?
Yeah, so I take that question. So when we think about Power Platform data flows, we think about two things. One is
Can't hear you. Can't hear you.
check. So when you think about Power Platform data flows, think about that as enterprise business integration, where essentially you have data not in the order of gigabytes or in the order of higher order of gigabytes or petabytes. And when you think about Data Factory, think in terms of enterprise data integration, where you're trying to do data, where you're trying to make conditional decisions based on if my 10th row failed, then what should I do and all of that, right? So if you attended our session yesterday, you would have seen that we have actually launched a public preview of what we call as wrangling data flows. And what that is, that we are allowing you to include your Power Platform data flow. So whatever Power Platform data flows uses, which is essentially Power Query, as a step in your Data Factory pipeline. But again, with Power Platform data flows, when you run that, it runs in memory. There is no big data portion to it. But in Data Factory, when you use that as a step, we take that business logic that you define, we translate that to Spark and run it over big data clusters in a managed way. So again, big data integration versus business integration. So that's the way to think about it. Yeah.
Just a question about the self-hosted runtimes. What are really the best practices for, we have a number of data sources at Gap that we need to extract data from. How many of these should I have? Is it really just performance, or are there other considerations we should think about?
For self-hosted IR, we have a suggested configuration for you to start with. So something you need to consider is number of concurrent runs. If your workload is minimal, there's a default concurrencies that is ADF auto-determined based on your machine spec. And if you are doing some micro kind of workloads, you can increase the concurrency as well. So I think you can start with that minimal that suggested configuration, and really you can choose to scale up of that machine, or tune the concurrency settings, which is the scale up, or you can scale out that to provision more nodes that to fulfill your growing needs.
Hi. So for the incrementals, you mentioned to use change tracking for SQL Server. Is there any support for the log file or log shipping?
You mean the CDC kind of mechanism?
That's right, because even with the CDC, you have to write SQL to get the deltas, whereas at least for the log file, all the deltas are there.
So we are looking into supporting CDC in the future, that is to using that built-in log mechanisms to retrieve the delta. This is something we are looking into. And I'd like to learn more on your scenario and see how that can fit in offline.
Hi. Using the file connector, if I want to write one templatized flow for hundreds of tables that all follow the same loading pattern, I have a database-driven source and target. How do you write a dynamic ADF? Instead of graphically drawing it, I have thousands of tables to process, and I need to make it table-driven data flows.
Yeah, so I share a kind of templatized, like metadata-driven pipeline. Is actually the similar configuration suggestion for your case as well. So in the pipeline, you just make that destination and source as parameters. And you can have a control table that contains each of the source and mapping to the destination if you want to have the file name and file destination. And you can do a lookup to look through those configurations and do a for each and pass to that as well.
It's not the connection string, it's the metadata types. Every single column. In one file, you have 50 columns. The next file, you have 20 columns. And they have different source to target mapping.
Yes, so not only the connection can be parameterized as well, and every configuration in ADF actually can be parameterized. So including the source and sink and queries. And for your question on schema, actually, if you don't need schema mapping, the default mapping is just retrieve everything and write to the destination. And you can express explicit column mapping as well, and that configuration can also be parameterized.
Now, can you do dynamic? Same thing if you're doing it, it's the file connector, and you're using Parquet format, and you're storing the metadata of your columns in there. If you have a matching target, you map the column names identical. You do an auto map.
Yeah, so by default, if you don't specify column mapping for all the data sources, we map columns by name. So it doesn't matter if it's a SQL database, it's a query return result, or it's a Parquet file which have the self-contained metadata. All those will just map by name. So if you don't want to map by name, then you can specify the explicit column mapping. Then you can map yourself as well.
So first of all, thank you for the excellent product. And important question, when is dark mode coming?
Sorry?
Dark mode.
dark mode?
Black mode, dark mode,
What?
for the editor.
Oh, your editor is you want the black visual?
Yes.
So we are actually looking at the bringing in different user settings. So right now, if you look at the UX, right, we don't have a concept of user settings where if you try, like let's say if you try to save your canvas, we don't allow you to save it, it automatically relays. Similarly, there is no coloring schemes and all of it. So that's something that we plan to target next semester. So we have a plan to do that. So that's good feedback to know that people are actually looking for it as well. Thank you. Yeah.
Regarding the bringing data from an on-prem SQL Server database, so you need the self-hosted IR, correct? Can that live on the cloud in a managed VM, or does it have to be installed on-prem?
So you can provision that either on-prem or in the cloud. In previous slide, I actually share the different network topology. If it's public network, you need to put that on-prem. If you have access route, you can put that in the VM. So as long as that machine have line of sight to the data store, it just works. And ADF doesn't do anything special. It's just from that machine connect to the on-prem, the network channel, the routes. It should go through ADF copy, just go through that.
Is there a preference which way? I mean,
There's a previous slice there. Sorry, it's a little bit far. This is the suggested way. So actually, if with Express route is the suggested way, that which is more secure and with predictable bandwidth, then that way put the self-hosted IR in the cloud. Otherwise, you can put that on-prem.
Hi, great presentation. So I have a couple of questions. First one around error handling.
Yeah.
So in my experience, I've just used in the monitor page to add an alert. So I'm looking at integrating that into the actual steps. So right now, it's kind of cumbersome to set up a web connector and a webhook, send an email. So is there anything in the future that would just handle that? I mean, send an email directly from ADF without provisioning tons of other services?
Yeah, so we are actually working on a first-class email activity. So it's in our roadmap for next semester. And we have received this feedback from other customers as well. So yes, you'll see a first-class email activity in the upcoming milestones.
Right. My second question, I forgot already. Yeah, thank you.
It's okay. Yeah.
My question is on data governance.
Okay.
Does ADF offer any data governance related capability or any plan to build such capability in ADF?
So when you say data governance, do you mean to say policies and catalog? So yes, we are working on integrating Data Factory with the catalog infrastructure, with the policy engine that we have recently acquired a company, and we in the upcoming releases in future, you'll see all of that tied together, integrated more with ADF. Yes, so we have plans to do that in future.
Any roadmap timelines?
So we don't have any timelines to share because we are still building those pieces. So, but in the upcoming releases or in the upcoming conferences, you will see some timelines from us, and in terms of specific features, what is coming when. Yeah.
Hi, XML data source. I didn't see that on the plan.
Yeah, XML is one of the common asks as well. This is on our plan to support that maybe for the next semester. So. Sorry?
Say next semester, is that next quarter?
H1, first half of next year. Yeah.
So what is the recommendation for VMI or high availability? Let's say we have one VM for IR. If it
You mean
VM
the
goes
self-hosted
down.
IR high availability? So it provides high availability with multiple nodes. So that's the suggested way. If one IR node died, the other one will pick up the job and keep moving. So you can set up just multiple nodes for each IR for that.
Thank you. And another thing is, let's say one ADF, if all our team is sharing, all the pipelines are available to all the developers, right? Is there a control that we can set at the folder level?
So today, the security boundary is your data factory. So whatever ACLs you can define or roles that we support with the AD integration, like contributor owner, are defined at the data factory level. But in future, we have plans to do allow you to support ACLing at a lower level as well, meaning pipeline data assessing services. But that's a work that we are going to do in future. But as of today, if you want to think about how many data factories you should provision, think about data factory as your security boundary, and whosoever you want to keep in a single security boundary, you need to have one data factory for that business unit or a set of developers in your organization.
So I remember my question. So
great.
We have a lot of Excel sources. So are there plans to include Excel connectors as well?
Excel is also another format popular, likely next semester as well.
Azure Synapse Analytics talks about having a, GUI, low, no-code ETL setup. Is that Azure Data Factory or something else?
Yes, it is all Azure Data Factory. So it is not a new version of Data Factory. It's the same Data Factory that you use. It's exactly same that is lit up in Synapse. So what we have done with Synapse is essentially when we talk about the MDW pattern, earlier you were using different set of services in the Azure Data Stack to build that, and you had to provision resources, then you essentially had to set up your link connections and all of it. So now we have, with Azure Synapse Analytics, everything from end to end, from provisioning to essentially having your MSI flow through all these Azure Data Services, to be able to build your pipelines, to be able to orchestrate that, monitor that, all of that is provided in that single canvas. So it is Azure Data Factory that is powering the data integration in Azure Synapse.
Okay, you're just making it possible to call it from the same GUI that you're sending SQL queries to the database as well.
Yes.
Okay, thank you.
Yep.
I'd like to hear your thoughts on having a multiple ADF in the one resource group. What is a use case like? Because I read it somewhere in the document saying that having like 3 different ADF.
So it depends on if you're trying to do continuous integration and delivery in your organization. So if you're trying to do CI/CD, where you have a dev data factory, a test, or a prod, so our recommendation is to have different data factories per environment, and then all of those can sit in a single resource group or a separate one, depending on whether you want all your developers or all your data engineers to have access to all of those environments. So that's depending on CI/CD, depending on what level of access you want, we can essentially chat about it on how you should be able doing it, whether a single resource group or multiple. So we're going to be kicked out of the room right now. There's another session, but you can stop by our booth in the expo hall, and we can discuss more on that and understand your scenario better. All right? Thank you, guys. Thank you.